Kumusta kayong lahat? Welcome to Mathstorya. Samahan niyo ako sa bagong topic natin ngayon, the hypothesis testing. So this hypothesis testing is a statistical procedure in which a choice is made between a null hypothesis and an alternative hypothesis based on information in the sample. So using this traditional method of testing a hypothesis, so we have the formula for the z-test. So z is equal to the sample mean minus the population mean or the hypothesis mean over the standard deviation, then divide by the square root of the sample size. And these are the things we need to remember, that if less than or below, this one is left-tailed. For greater than or more, that's right-tailed. And for not equal or difference, this one is two-tailed. So this less than and greater than are both one-tailed. So let's solve this problem. So find the rejection region for the standardized test statistics for each hypothesis test. So we have this null hypothesis given, the h sub 0. So we assume that the hypothesis mean is equal to 31. And for the alternative hypothesis, that's h sub a, so we need to test if the hypothesis mean is less than 31. Since this one is less than, so therefore it's on the left-tailed. And our level of significance, that's the alpha, that's 0.10. So to find now the rejection region, so in a normal curve, since left-tailed, so this one is one tail. And the level of significance is 0.10. So under one tail, so we have this 0.10. So z now is equal to 1.282. But since the given is left-tailed, so therefore to the left, and the sign to the left is negative, so the value now is negative 1.282. So this is now the rejection region. So all numbers to the left of negative 1.282. So the rejection region now, so z is less than or equal to negative 1.282. Then for this given, so our null hypothesis, the hypothesis mean is equal to 42. Then for the alternative hypothesis, so we need to test if the hypothesis mean is not equal to 42. Now, since not equal, so this one is two-tailed. Then our level of significance, that's the alpha, that's 0.05. So to find now the rejection region, so in a normal curve, since two-tailed, so we have this two-tailed, and under two-tailed, the level of significance, that 0.05, so this is 0.05. So z now is equal to 1.96. Since two-tailed, so therefore 1.96 to the left and also 1.96 to the right. But to the left, the sign is negative. This one is negative 1.96. And to the right, that's positive 1.96. So this is now the rejection region. So all numbers to the left of negative 1.96 and all numbers to the right of positive 1.96. So the rejection region now, so z is less than or equal to negative 1.96 or z is greater than or equal to 1.96. Then for this given, so the null hypothesis, so the hypothesis mean is equal to 63 And for the alternative hypothesis, so we need to test that this hypothesis mean is greater than 63. So since greater than, so therefore this one is right-tailed. And our level of significance, the alpha, that's 0.01. So to find now the rejection region, since right-tailed, so this one is one tail. Then under one tail, we have this 0.01. So Z now is equal to 2.326. Since right-tailed, so therefore positive 2.326. So this is now the rejection region. So all numbers to the right of 2.326. So the rejection region now, Z is greater than or equal to 2.326. And then for this problem, so a random sample of 85 students who passed a general mathematics course, the average score was 72.4. Assuming that the population standard deviation is 9.1 with a significant level of 0.05. Thus, it seems to signify that the average score is more than 70. So this 70 is the hypothesis mean. Then we need to test that the average score is more than 70. So first, we need to list the given. So N, that's the sample size. So since we have a random sample of 85 students, so N is equal to 85. And from that 85 students, we have an average score of 72.4. So the sample mean is equal to 72.4. Then the standard deviation, that's 9.1. And the hypothesis mean, that's 70. So these are now the steps in hypothesis testing. So first, we need to state the null and the alternative hypothesis. So for our null hypothesis, we assume that the hypothesis mean is equal to 70. And for our alternative hypothesis, we need to check that the average score or the hypothesis mean is more than 70. So this one is the null hypothesis and this one is the alternative hypothesis. Then step 2, specify the level of significance. Since our level of significance is 0.5, so alpha is equal to 0.5. Then since this one is more than, so this is right-tailed. Then for step 3, so we need to identify the critical values or the rejection region. So since right-tailed, so one tail, then alpha is 0.05. So Z now is 1.645. Then right-tailed, so to the right, so positive 1.645. So this is now the rejection region. And this area is the non-rejection region. Then for step 4, the computation. So using this z-test formula, so Z is equal to the sample mean, that's 72.4, then minus the hypothesis mean or the population mean, that's 70, then divide by the standard deviation, that's 9.1 over the square root of the sample size, square root of 85. Then to solve for Z, so this 72.4 minus 70, that's 2.4. Then this 9.1 divided by square root of 85. So 9.1, then divide by the square root of 85. So we have 0.9870. So 0.9870. So to solve now for the value of Z, so this 2.4 divided by 0.9870, that's 2.43. So Z is equal to 2.43 2.43. Then from the rejection region, since the rejection region, that's Z, is greater than or equal to 1.645, because all numbers to the right of 1.645. So this is the area we reject the null hypothesis. So for step 5, since Z is equal to 2.43 and the rejection region or the critical value, that's 1.645, and this 2.43 is greater than 1.645. Since the value of Z is greater than 1.645, so therefore Z belongs to the rejection region, so we reject the null hypothesis. Since we reject the null hypothesis, so we accept the alternative hypothesis. So we conclude that the hypothesis mean is greater than 70. So we conclude that the average score is more than or greater than 70. And then for this problem, so in the past, the average length of an outgoing telephone call is 130 seconds. So this 130 seconds is our hypothesis mean or the population mean. Then a manager wishes to check whether that average has decreased, so less than, after the introduction of policy changes. Then a sample of 50 telephone calls produce a mean that's 125 seconds with standard deviation of 35 seconds. Perform the relevant tests at 1% level of significance. So first, we need to list all the given. So and the sample size. So a sample of 50 telephone calls. Then the mean. So produce a mean that's 125 seconds. So this one is the sample mean. Then for our standard deviation, so that's 35 seconds. And for the hypothesis mean or the population mean, that's 130 seconds. So to solve this one now using the steps in hypothesis testing, so first we need to state the null and alternative hypothesis. So for our null hypothesis, so we assume that the hypothesis mean is equal to 130 seconds. Then for the alternative hypothesis, so we need to test if the average decrease or less than 130 after the new policy. So this is now the null hypothesis and this one is the alternative hypothesis. Then for the level of significance, since 1%, so alpha now is equal to, so this 1% in decimal, that's 0.01. Since less than, so therefore this one is left-tailed. Then for the rejection region or the critical value, since left-tailed, so one tail, then the alpha, that's 0.01, so 0.01. So Z now is equal to 2.326. But since left-tailed, so to the left, so the value is negative 2.326. So this is now the rejection region and the non-rejection area. Then for the computation, so Z, so we have this, the sample mean, that's 125 minus the hypothesis mean is 130, then divide by standard deviation, that's 35, over the square root of the sample size, that's 50, then simplifies. So this 125 minus 30, that's negative 5. Then this 35 divided by square root of 50. So 35 divided by square root of 50, that's 4.9497. So to solve now for Z, so negative 5 divided by 4.9497, So Z is equal to negative 1.01. Then from the rejection region, since we reject the null hypothesis, if the value or Z is less than or equal to negative 2.326. So all values to the left of this negative 2.326. So for step 5, since Z is equal to negative 1.01 and the critical value is negative 2.326, since Z is greater than negative 2.326, so Z is inside this non-rejection area. So therefore, we accept or do not reject the null hypothesis because Z is inside the non-rejection region. Since we accept the null hypothesis, so we reject this alternative hypothesis and we accept this null hypothesis. So the hypothesis mean is equal to 130. So we conclude that the average length of an outgoing call is still equal to 130 seconds.